Okay, so 5.2, number 52, about the Iceman. So in 1991, yes? Dead guy. Found in ice. Which I'm sure was confusing as hell for the local cops for a minute. Right? Like whoever finds this doesn't go, oh yeah, that guy's clearly been there for thousands of years. They go, ah! and run to the local cops.
I mean the local cops run to the local cops?
No, whoever finds it runs to the local cops, and then the local cops are like, oh shit, someone's been murdered. Quick, account for all the people. Right? And they're not going to find this guy in the missing persons database. Right? All right, so we found this dead guy. Cool.
Cool.
Dead guy had 46% of his carbon-14 remaining.
I want some carbon-14.
You have some carbon-14, buddy. We all do. So 46% of his C14 remains.
Actually, it's 14 goes behind and up.
What?
Yeah. Because that would be 14 carbon atoms.
This one?
Mm-hmm. Yeah, because if you put 14, that's 14 carbon atoms.
Yeah, he's right. I don't know whether it goes up here or there.
Yeah.
But it's definitely not the bottom right one.
Yeah.
Because that would be 14 carbon atoms stuck together. Okay, so this is the isotope carbon-14, which you all get by what? You all have some of this. Where do you get it?
Yo, I don't know.
Food.
Carbohydrates?
Yeah, you absorb that from food. So what we believe, right, is that this dude has 46% of his carbon-14 remaining. He was getting that from his food. When did he stop getting food? Probably give or take 3 days before or after he died, right? Well, probably not after. Right. Okay, so then they tell me that carbon-14 has a half-life of 5728 years. Okay. Where did they get that information? How is it known? Yeah. How would you figure this out? Science. Yeah, so you can figure this out in the example, right? Because you know how those population models work. So what you do is you get yourself some carbon-14, right? And then you let it sit in a closet for a while, and then you come back and measure it later to see how much carbon-14 is still there, right? And then you do this little pre-calculus problem to figure out what the half-life is. You don't need to watch half of it decay. You just need some of it to decay, right? So you don't need to wait 5,700 years. You could probably get away with 3 or 4, right, to calibrate your model. Okay, so what am I interested in?
When he died.
Yeah. When was this dude kicking around? So how do I figure that out?
Plug it into some sort of equation that deals with percentage of time.
Okay. So I know that the half-life is 5728 years, right?
So 1/2 to the E.
So that means that 1/2 is
E to the K times 1,000.
e to the 5728 times k. Right? So log divide. Get k is minus the natural log of 2 over 5728.
That should give you
Okay, then what?
a year. Should that give you a year? Or
This will give me the decay rate for carbon-14.
then you plug that back into...
Then I plug that back into basically this thing again,
Yeah.
right? So what do I know? I know he has 46% of his carbon-14. So is that a time or an amount?
Amount.
That's an amount, right? So 0.46 of his carbon-14 is
To the nothing of
1, right? You want 1.
1, because he started with 100% of his carbon-14, right?
Hopefully.
And then there's a e to the
that number.
this number
Yeah.
minus the log of 2 over 5728 times
T.
times t. And then I want to solve. Good with this?
E.
Okay, so if I solve this, I'll get natural log of 0.46 divided by, like,
What did you do there?
alpha.
Same.
I logged both sides, right? Okay, fine. Log both sides, right? You log both sides, you get log of 0.46 equals minus the log of 2 over 5728 t.
Okay.
And then what? I'd probably multiply both sides by 5728 over negative the natural log of 2. Right?
Multiply by the reciprocal.
Or multiply through by 5728 and then divide by negative natural log of 2. Like, however you make this happen is totally up to you. If you want to do more steps, hit it. Like, really do it. So I got natural log of 0.46 times 5728 over negative natural log of 2. And that's going to be my time t. Somebody want to crank on that in a calculator? What are you umming at me?
Negative.
Oh yeah, negative.
Negative time, is that because you want to go back in time to when he died, but that doesn't make sense to have a negative time.
Yeah, negative time wouldn't make sense.
But
luckily, log of 0.46 is negative.
oh, okay.
You guys with me on that?
Okay.
6,417.
Okay, is that ballpark reasonable? So like t is basically 6,700.
Years ago, then you yeah.
Yeah, years ago.
Because more than half of the carbon-14 has decayed.
Yeah, I know it's been at least 5,700 years, right? Because half of it's gone, right? So it had to get a little past half. So what's a little past half? Well, a little past 5,700. 6,700's
It's 10,000.
ballpark-ish,
It's not bad.
right? Cool. Do not do the silly thing about 80 BC subtracting.
Oh, 80.
80 and BC. If you want to convert this to BC, you don't get to subtract that from this,
Oh, yeah.
right? Because BCs aren't actually negative because there's no 0 year.
There was no 0 year.
Yeah, there was never a year called 0, which is weird.
So would you just
It
have
just
to?
goes
Don't worry about it.
400.
It's an approximation anyway.
If we were to standardize the years and get rid of BC AD thing, could we?
And then
Sure,
we-
yeah, it's just an arbitrary declaration.
Then we
So we
just
just have to pick a date to set as 0?
Yeah, you could start today.
But I mean, we're cool, we can switch over to like the metric system.
I wasn't saying it was feasible.
Start with a big bang.
All right.
Yeah, it's definitely not feasible. So there are different counting systems for calendars. One of the more hilarious ones is the time seed for a Linux computer. They're all standardized off a universal time server, which started counting when they first turned a Linux machine on ever.
Oh, so they're probably at what year?
It counts in milliseconds.
Oh.
So it's milliseconds since Linux was invented, is how the Linux clock works.
Ooh.
And it converts, right?
Hmm.
Just like we convert to metric, right, with sockets.
It's that little symbol up there, the T something 67.
Oh, this guy?
Yeah,
That is supposed to be a squiggly equal.
Okay, it looked a
I
little
just
bit-
drew it fast.
it looked a little bit like something from World War II that I won't.
Thanks. Yeah, I appreciate you keeping my notation clean and
I don't want you to get arrested.
acceptable.